Spillover, Animal Infections and the Next Human Pandemic by David Quammen. Picture a peaceful Brisbane neighborhood back in 1994. Racehorses graze lazily in backyard stables, and life hums along at an easy rhythm. Then, one September morning, everything changes. A champion mare named Drama Series, heavy with foal, starts acting strange. Nothing alarming at first, just wrong. Her sharp-eyed trainer, Vic Rail, brings her in from the paddock. She's dragging her feet, her face looks puffy, and she won't touch her favorite treats, not even carrots drizzled with molasses. Vic rings up Dr. Peter Reed, the local vet. What he finds is worrying. Drama Series is physically depressed, running a fever, her heart racing. He administers antibiotics and painkillers before heading home. But midnight brings a frantic phone call. Drama Series has collapsed, and she's fading fast. By the time Dr. Reed races back to the stables, it's too late. Her death is swift and brutal. She staggers, crashes to the ground, hurts herself thrashing about. Vic and a stable hand named Ray Unwin struggle to hold her down as frothy liquid bubbles from her nostrils. Then she's gone. A tragic loss for a racehorse, sure. Maybe a snake bite? Poisonous weeds? Nobody has answers. They haul away her body, just another casualty in the unforgiving world of horse racing. But 13 days later, the true horror begins. Her stablemates start dropping like flies. One after another succumbs to fever, labored breathing, bloody foam pouring from noses and mouths, violent spasms, disorientation. Some bash their heads against stable walls as if driven mad. 12 more horses either die horrible deaths or receive mercy from Dr. Reed's needle. 7 perish in just 12 hours. The speed with which it went through those horses was unbelievable, Reed would recall later. The nightmare doesn't stop at the stable doors. Vic Rail gets sick. So does Ray Unwin, the stable hand. It looks like a nasty flu initially. Vic ends up hospitalized, deteriorates rapidly, and after a week in intensive care, he's dead. His lungs choked with fluid, blood, and something else, something microscopic and deadly. Ray Unwin fights through it at home and pulls through, though he's never quite the same afterward. Strangely, Dr. Reed remains perfectly healthy. So what was this invisible assassin that could leap from horse to human with such lethal efficiency? Where did it originate? And why did it suddenly appear in this quiet Brisbane suburb, seemingly from thin air? These questions sit at the very heart of an incredibly important book called Spillover, Animal Infections and the Next Human Pandemic, written by the gifted science writer David Quammen. Quammen's a true master storyteller who crisscrosses the globe, interviews scientists working on the front lines, and returns with tales that are simultaneously thrilling and deeply unsettling. Spillover, published in 2012, became a bestseller and remains profoundly relevant today, maybe even more so than when it first hit shelves. It takes us on an edge-of-your-seat journey into the world of emerging diseases, those frightening new illnesses that seem to explode onto the scene, threatening everyone. And here's what I can promise you. By the time we finish exploring the core ideas of this book today, you'll grasp a fundamental truth about our world. A truth that links your health and mine to the health of animals in the planet's most isolated corners. You'll understand why these new diseases are popping up more frequently and what that means for our future. You'll understand the concept of zoonosis. It's probably a word you haven't heard much, but it's a word that shapes our reality. So let's start there, with that word, zoonosis. What does it actually mean? David Quammen explains it beautifully simply. A zoonosis is an animal infection that can jump to humans. Think about that for a moment. We usually think of human diseases and animal diseases as completely separate categories. But Quammen, drawing on deep scientific understanding, reminds us of something fundamental that Charles Darwin himself pointed out. We humans are animals, inseparably linked to all other animals on Earth, in sickness and in health. And here's the kicker. These zoonotic diseases are way more common than you'd think. About 60%, more than half, of all known human infectious diseases originally came from animals, or still bounce back and forth between us and them. AIDS? Zoonosis. Every type of influenza, including the catastrophic Spanish flu of 1918 that killed perhaps 50 million people? Zoonoses, ultimately tracing back to wild birds. Ebola, that terrifying virus from Africa? Zoonosis, bubonic plague, Lyme disease, West Nile fever, rabies, even bizarre new ones like Nipah virus that killed pig farmers in Malaysia. All zoonoses. Now compare this with diseases like smallpox or polio. These come from viruses that, under natural conditions, only infect humans. They don't have another animal species to hide out in, and that's a crucial difference. It helps explain how massive global efforts, like the one led by the World Health Organization, could successfully wipe out smallpox by 1980. Because the virus had nowhere else to go, nowhere to hide outside of human bodies or carefully secured labs. Polio is hopefully heading toward the same fate, precisely because it's not zoonotic. But zoonotic diseases? They can hide. They can lurk, invisible, within what scientists call a reservoir host. A reservoir host is a living organism, maybe a bat, a rodent, a bird, that carries the pathogen, often for long periods, without getting seriously sick itself. Think of it as a secret hideout for the virus, or bacterium. When a disease seems to vanish between outbreaks, like the Hendra virus did after that first terrible incident in Brisbane, where does it go? It doesn't just evaporate from the planet. Usually, it's still hanging around nearby, quietly living within its reservoir host. And these secret hideouts are often found where biological diversity peaks, in relatively undisturbed ecosystems like rainforests. But here's a critical point. Quammen drives home. When we disturb those ecosystems, when we bulldoze forests, carve roads, hunt wild animals, we shake things up. As he puts it, shake a tree and things fall out. Those things include microbes, viruses, bacteria, fungi, and others that normally live quietly within their specific hosts. When their homes are demolished and their hosts are killed or scattered, these microbes face a stark choice: find a new host or disappear forever. And guess who makes a very convenient, very abundant new host? Us. Humans. We're everywhere. There are over 7 billion of us now. As the historian William McNeill noted, from the perspective of a hungry virus, humanity offers a, quote, magnificent feeding ground. We're not necessarily targeted, Quammen stresses. We're just available. Especially vulnerable are the rapidly adapting RNA viruses, like influenza, like HIV, like Ebola, Hendra, Nipah, and SARS. They mutate quickly, constantly experimenting with new ways to survive and spread. So the stage is set. We tear apart ecosystems, we bump into animal microbes we've never encountered before. And our sheer numbers and interconnectedness through global travel give any newly adapted pathogen a golden opportunity to spread like wildfire. This, Quammen argues powerfully, is the underlying reason we're seeing more and more of these emerging diseases. Let's circle back to that Hendra virus outbreak in Brisbane. Identifying the virus, initially called equine morbillivirus or horse measles, later renamed Hendra, was just step one. The next crucial question was, where did it come from? Where was its hiding place, its reservoir host? The search fell to a dedicated veterinarian-turned-ecologist named Hume Field. Field started where the story began, at the paddock where drama series first showed symptoms. He trapped rodents, possums, birds, reptiles, anything that moved, and tested their blood for antibodies, signs of past infection. Nothing. He wondered if maybe the timing was off, or the location. Then came another clue. Tragically, a year later, and hundreds of miles north, near a town called Mackay, a young farmer named Mark Preston died of severe brain inflammation. Tests revealed he had antibodies to Hendra virus, and the virus itself was found in his brain tissue after death. Investigators learned that 2 horses had died suddenly on his farm the previous year, just before the Brisbane outbreak, and Mark had helped his wife, a veterinarian, care for them and perform autopsies. Preserved tissues from those horses now tested positive for Hendra. Remarkably, his wife stayed healthy, just as Dr. Peter Reed had in Brisbane. It seemed, as one research group concluded, that very close contact is required for the virus to jump from horses to humans, plus maybe some bad luck or other unknown factors. This second outbreak gave Hume Field another data point on the map. He traveled to Mackay, repeated his trapping and testing. Still nothing. Frustration mounted. Millions of dollars in the racing industry hung in the balance, not to mention human lives. Field and his colleagues brainstormed. The reservoir host, whatever it was, had to exist in both places, Brisbane and Mackay, or be able to travel between them. Suspicion fell on mobile creatures, birds and bats. They leaned toward bats. Bats are mammals, like horses and humans. Bats get around. And bats were known to harbor rabies, though not then in Australia. Remember Dr. Reed's comment about the paddock where drama series got sick? A local resident had said that at night, flying foxes were as thick as the stars in the sky. Flying foxes are magnificent fruit-eating megabats native to Australia, with wingspans of 3 feet or more. Field turned his attention to them. Catching flying foxes wasn't easy, but he found a shortcut through a network of wildlife carers, dedicated amateurs who rehabilitate injured animals. At a facility up the coast, he found injured black flying foxes. Jackpot. Blood from one tested positive for Hendra antibodies. Soon, antibodies turned up in the 3 other species of Australian flying fox as well. Testing archived samples showed bats had been exposed long before the 1994 outbreak. The final piece of evidence came when a pregnant gray-headed flying fox, caught on a fence, miscarried. Her uterine fluid yielded live Hendra virus, indistinguishable from the strains found in horses and humans. The case was solid. Flying foxes were identified as the probable reservoir hosts. Further surveys revealed something startling. Nearly half of the flying foxes tested showed evidence of past or present infection. Half! It seemed like Hendra virus should be raining down constantly. This discovery caused alarm, naturally. Bats already had a public image problem, and now they were linked to a deadly virus. Some people, like one furious racehorse trainer Quammen interviewed, demanded exterminating the bats. Even the dedicated bat carers grew worried, both for the bats' reputation and for their own safety. Could they get infected handling these animals? An epidemiologist named Linda Selvey tested 128 bat carriers, many of whom had years of close contact, including scratches and bites. The result? 0 infections. Not a single person showed antibodies to Hendra virus. How could this be? Half the bats, potentially carrying the virus, intimate human contact yet no transmission. What did this tell Selvey about the virus? That it needed some sort of amplifier, she told Quammen. And that brings us to another key concept, the amplifier host. Sometimes, a pathogen can't easily jump directly from its reservoir host to humans. It needs an intermediate step, an animal in which the virus can multiply to extraordinarily high levels, becoming abundant enough to overcome the barriers to infecting a different species, like us. Think of foot and mouth disease, mainly affecting cattle and sheep. Pigs can get it too, but they play a special role. They excrete vastly more virus than other livestock, especially in their breath, broadcasting it for miles. Pigs are amplifier hosts for foot and mouth virus. Linda Selvey suspected, and evidence supported, that horses play a similar role for Hendra. The virus spills from bats, perhaps through urine or birthing fluids contaminating pastures where horses graze. It finds a hospitable environment in the horse, multiplies massively, and then, in the bloody froth and other fluids of the sick horse, reaches high enough concentrations to potentially infect a closely exposed human. Horses, Quammen notes, aren't native to Australia. They arrived with European settlers just over 2 centuries ago. The virus, the bats, and humans had likely coexisted for thousands of years before that. So why did Hendra wait until 1994 to emerge? Or had it emerged before, perhaps mistaken for something else? These remain open questions. The Hendra story, Quammen shows us, is a small-scale version of a larger, unsettling pattern. The emergence of Hendra in 1994 wasn't an isolated incident. It was one beat in a drumbeat that's been getting louder and faster over the past half-century. Think of the list: Machupo virus in Bolivia in the early 60s, Marburg in Germany from imported monkeys in 1967, Lassa fever in Nigeria, 1969, Ebola's terrifying debut in Zaire and Sudan, 1976. HIV recognized in 1981, hantavirus in the American Southwest, 1993, Hendra, 1994, avian flu in Hong Kong, 1997, Nipah in Malaysia, 1998, West Nile, arriving in New York, 1999, SARS exploding out of China in 2003, swine flu causing global panic in 2009. These aren't just random unfortunate events, like earthquakes or meteor strikes. Quammen argues powerfully that they're connected. They're largely the unintended consequences of our own actions. He identifies 3 key elements driving this pattern. 1. We humans, all 7 billion plus of us, are tearing apart natural ecosystems at an alarming rate through logging, agriculture, mining, urban sprawl, pollution, climate change, you name it. Tropical forests, the richest ecosystems, are particularly affected. 2. These ecosystems harbor millions of species, including countless unknown viruses, bacteria, and other microbes, many of them parasitic. Each microbe lives within specific ecological relationships, often quietly coexisting with its host. The viruses that cause Ebola, Marburg, Lassa, and HIV are just a tiny sample of what's out there. 3. As we disrupt these ecosystems, we shake these microbes loose from their natural hosts and habitats. Like dust from a demolished building, they fly out. Deprived of their usual hosts, they seek new ones. And we, humans, are abundantly, obtrusively available. Especially adaptable are the RNA viruses, prone to rapid mutation and evolution. This convergence, ecological disruption meeting microbial adaptability and human ubiquity, is what fuels the emergence of new zoonotic diseases. Perhaps the most terrifying example Quammen explores is Ebola. He takes us back to Central Africa, to places like Mayabout in Gabon, the village we heard about earlier through the memories of Thony McBoth and Sofiano Etuk. In 1996, villagers there found a dead chimpanzee in the forest. They butchered it, they ate it. Within days, 18 people fell violently ill, with fever, vomiting, bleeding, bloody diarrhea. Ultimately, 31 people got sick and 21 died, a staggering fatality rate near 70%. The cause? Ebola virus, traced back to that scavenged chimpanzee. Thony and Sofiano told Quammen they also saw something bizarre around that time. 13 dead gorillas piled up nearby in the forest. Quammen joins researchers like Billy Koresh, a field veterinarian, tracking the aftermath of an Ebola outbreak that reportedly killed thousands of gorillas near the Lasi Sanctuary in Congo. They spend days searching for survivors, finding almost none. The forest is eerily empty, where gorillas were once abundant. The inescapable conclusion, something, very likely Ebola, had wiped them out. This raises the same crucial question as with Hendra: where does Ebola hide between these devastating appearances? The search for Ebola's reservoir host has been one of the biggest, longest-running mysteries in infectious disease research, dating back to the first recognized outbreaks in Yambuku, Zaire, and Sudan in 1976. Early investigations looked at bedbugs, mosquitoes, rodents, monkeys, even bats, but found nothing. A massive effort after the Kikwit outbreak, trapping thousands of animals, also came up empty. The virus seemed to vanish completely between human and ape tragedies. Like Humefield with Hendra, researchers like Eric Leroy strongly suspected bats. Leroy's team trapped over 1,000 animals in Ebola-stricken areas, including hundreds of bats. They found evidence, antibodies, and fragments of viral RNA, suggesting Ebola infection in 3 species of fruit bat, including the huge hammer-headed bat, which people hunt for food. But crucially, they couldn't isolate live virus from any bat. That remained the missing piece of definitive proof. Quammen also dives into the human side of Ebola, contrasting the often sensationalized accounts, like those in Richard Preston's The Hot Zone, of victims melting down or bleeding out, with the more complex, though still terrible reality described by experienced responders like Pierre Roland and Carl Johnson. Yes, bleeding occurs in some cases, but many patients die from other causes, like organ failure and shock, often related to the virus devastating their immune systems. He also touches on local understandings, where outbreaks are sometimes attributed to sorcery or evil spirits like Izanga or Jimo, reflecting deep cultural beliefs about disease and misfortune, some of which, like quarantine practices, align surprisingly well with modern public health measures. A crucial point about Ebola and many similar viruses like Hendra and Marburg is their limited ability, so far, to transmit efficiently from person to person. They often reach a dead end in human hosts. While devastating locally, they haven't ignited sustained widespread epidemics. Each spillover, however, as Quammen notes, is like the virus buying a lottery ticket, a long-shot chance to adapt, to become more transmissible, to achieve a more grandiose existence. Sometimes, the better wins big. And that brings us to HIV, the virus that won the lottery. Quammen dedicates a significant portion of Spillover to unraveling the origin of AIDS, arguably the most impactful zoonotic disease of our time. He dismisses the early, often misleading narratives, the focus on gay men in Los Angeles. Michael Gottlieb's initial report, Kaposi's sarcoma in New York, Alvin Friedman Keene, or the infamous Patient Zero, Gaetan Dugas. These were crucial moments in recognizing the epidemic, but they weren't the beginning. The real story, he shows, starts much earlier, and in Africa. But the origin of the pandemic strain, HIV-1, remained elusive for longer. Early clues came from Martine Peters, who, while working in Gabon, found a virus in captive chimpanzees, SIV-CPZ, that closely resembled HIV-1. But skepticism remained. Were these just cage infections? Was the virus even present in wild chimps? The breakthrough came largely through the work of Beatrice Hahn and her team, utilizing ingenious, non-invasive sampling methods developed by researchers like Mario Santiago and Brandon Keel. Instead of needing blood samples, difficult and risky with wild chimps, they learned to detect viral antibodies in urine and, crucially, fragments of viral RNA in fecal samples preserved in a special liquid. This allowed them to screen hundreds of samples collected from wild chimpanzee communities across Central Africa. Their findings were stunning. They confirmed that SIV-CPZ does infect wild chimpanzees, but its prevalence varies dramatically. In most areas, it's rare. But in one specific region, the remote southeastern corner of Cameroon, near the borders with Congo and Central African Republic, prevalence rates soared as high as 35% in some communities. And the viruses found there were shockingly similar to human HIV-1, particularly the pandemic strain Group M. The genetic evidence was overwhelming. The AIDS pandemic originated from a spillover of SIV-CPZ from the central chimpanzee subspecies, pan-troglodytes, living in that specific region of Cameroon. Further research, notably by molecular phylogeneticist Michael Warabi, using archived human tissue samples from Kinshasa, formerly Leopoldville, dating back to 1959, ZR59, and 1960, DRC60, pushed the timeline back even further. By comparing the genetic divergence between these old viral sequences and applying a molecular clock based on HIV's known mutation rate, Warabi estimated that the original spillover likely occurred around 1908, give or take a decade. This definitively debunked the controversial theory that HIV originated from contaminated oral polio vaccines tested in Africa in the late 1950s, the OPV hypothesis. The virus was already in humans decades before those trials began. So how did the spillover happen? The most plausible explanation remains the cut hunter hypothesis. Around 1908, in southeastern Cameroon, a hunter killed an SIV-infected chimpanzee. While butchering the animal, the hunter got chimpanzee blood into an open wound. The virus crossed the species barrier, adapted slightly, and became HIV-1. Quammen vividly imagines this scenario, tracing the virus's likely path. Smoldering at low levels in remote villages, passed along through sexual contact, until eventually, perhaps carried by someone traveling for trade or work, his imagined voyager, it reached the burgeoning colonial cities on the Congo River, Brazzaville, and Leopoldville, Kinshasa. Once in the urban centers, likely around the 1920s or 30s, the virus found fertile ground. Rapid population growth, changing social structures, gender imbalances leading to commercial sex work, and potentially widespread use of unsterilized needles in colonial medical campaigns, as researched by Jacques Pepin, created the, quote, perfect storm for HIV-1 Group M to amplify and spread. From Kinshasa, it radiated outwards, subtype B traveling to Haiti, likely via Haitian professionals working in post-independence Congo around 1966, and from there to the United States around 1969, other subtypes spreading across Africa and eventually the globe. Throughout Spillover, Quammen weaves these gripping narratives of disease detective work, chasing Hendra, Ebola, SARS, Nipah, HIV, and others back to their animal sources, with deeper reflections on ecology and evolution. He introduces us to the mathematical modeling of epidemics, concepts like R0, the basic reproduction rate, determining if an outbreak grows or fizzles, and the complex interplay between a pathogen's virulence, how deadly it is, and its transmissibility, how easily it spreads. He shows, through examples like the myxomovirus in Australian rabbits, that evolution doesn't necessarily favor harmlessness. Sometimes, intermediate levels of virulence can maximize a pathogen's ability to spread. He brings us face to face with the researchers doing this vital, often dangerous work, people like Hume Field tracking bats in Australia, Eric Leroy and his team investigating Ebola in Gabon, Beatrice Hahn and Michael Worraby painstakingly tracing the origins of HIV through genetic sequences found in decades-old samples, John Epstein netting Nipah-carrying flying foxes in Bangladesh, and Greg Dwyer studying viruses that cause gypsy moth caterpillars to literally melt. Their collective work points toward that central theme, our ecological entanglement. We're part of the web of life, not separate from it. And as we continue to tear at that web, we shouldn't be surprised when things, dangerous things, like novel viruses, fall out and land on us. The emergence of these diseases isn't just bad luck. It's often a reflection of how we're treating the planet and the other species we share it with. Quammen ends not with predictions of doom, but with a call for understanding and preparedness. We can't know exactly what the next big one will be, or when it will arrive, but we know it will likely be a zoonotic virus, probably an RNA virus emerging from wildlife. We know that our actions, habitat destruction, the wildlife trade, intensive livestock farming, global travel, increase the risk. But we also have the capacity for intelligence, for foresight, for cooperation. We have scientists acting as sentinels, developing tools for rapid detection and response. The ultimate outcome, Quammen suggests, depends not just on the viruses, but on us, on our choices, our behaviors, our willingness to understand our place in the world. It depends. Reading Spillover, or even just hearing this summary, leaves you with a profound sense of connection and perhaps a little unease. It's a powerful reminder that the health of humanity isn't separate from the health of the planet and its diverse inhabitants. David Quammen masterfully illustrates how our interactions with the animal world, often driven by expansion, consumption, and disruption, can have unforeseen and sometimes devastating consequences. These aren't just fascinating scientific mysteries, they're urgent ecological and public health realities. The core message, I believe, is one of responsibility. The emergence of diseases like Hendra, Ebola, SARS, Nipah, and HIV isn't purely random misfortune falling from the sky. While chance certainly plays a role in which virus jumps when and where, the frequency and opportunity for such jumps are things we're actively influencing through our collective actions. Cutting down a forest in Borneo might seem distant, but, as Quammen shows, it can create the conditions for a virus lurking in a bat to find its way, perhaps via a monkey and a mosquito, into a human traveler who then boards a plane to Helsinki. It's all connected. So what can we take away from this, practically speaking? It's not about living in fear of every bat or avoiding travel. It's about cultivating awareness and making more informed choices. First, understand the connections. Recognize that our health depends on the health of ecosystems. Supporting conservation efforts, protecting biodiversity, and advocating for sustainable land use aren't just environmental issues. They're public health imperatives. Intact ecosystems with diverse species, as the Lyme disease research suggests, can sometimes act as a buffer, diluting the impact of potential pathogens. Disrupted, simplified ecosystems often amplify the risk. Second, be mindful of consumption. The global trade in wildlife, whether for food, pets, or traditional medicine, creates countless pathways for pathogens to travel and spill over. Being conscious of where our food comes from, avoiding exotic animal products, and supporting regulations against illegal wildlife trade can make a difference. The conditions in live animal markets, as described in the context of SARS, are stark examples of how proximity and stress can facilitate disease transmission. Third, support the science and public health infrastructure. The scientists' Quammen profiles are our sentinels. Investing in disease surveillance, rapid diagnostics, research into vaccines and treatments, and strengthening public health systems globally is crucial for detecting and responding to outbreaks before they become pandemics. Ultimately, Spillover is a call to humility. It reminds us that we're one species among many, sharing a planet teeming with microbial life that has been evolving for billions of years longer than we have. These microbes aren't inherently malevolent. They're simply surviving, adapting, and seizing opportunities. As we continue to reshape the planet at an unprecedented scale, we're creating countless new opportunities for them. Understanding this dynamic is the first step toward navigating our future more wisely. That was a journey through the core ideas of Spillover by David Quammen. We've touched on the major themes, the key diseases, and the critical scientific concepts today. But honestly, a summary like this is just scratching the surface. The real depth, the nuance, the incredible stories of scientific discovery and human tragedy, those are found within the pages of the book itself. This overview is here to help you gauge if this exploration resonates with you, if these questions about our interconnected world spark your curiosity. If you felt that spark today, I truly encourage you to pick up a copy of Spillover. Reading Quammen's full account isn't just about absorbing information. It's an immersive experience that might fundamentally alter how you view our relationship with the natural world and the invisible forces that shape our health. You can find a link to the book in the description below. Also, if this summary provided you with some valuable insights, or simply a good story well told, please consider hitting that like button and subscribing to the channel. That way, you won't miss our next exploration into another fascinating book that has shaped minds and perhaps even changed the course of lives. Let's continue this journey of learning and discovery together.